Hello guys, today we are going to talk about the car black box project. This is a project we did during our internship at Emertxe. The project is presented by John Mamicha and Patrick Mahinda. Welcome. So what we learned in the entire internship include C programming. And in C programming, we did introduction to C, data types in C, operators and arrays, pointers and functions, storage classes and preprocessors. Under project requirement and design, embedded system programming, we were introduced to embedded systems, installation of the development tools, we were introduced to microcontrollers, and we did all the project using PixSimLab, Simulator, and MPLab IDE. We also did peripheral programming where we did LED interfacing, digital keypads interfacing, interrupts and timers. We were introduced to analog to digital converters, CLCDs, and I2C communication protocol. Finally, we did our project integration where we integrated our project and did the tests. Now welcome. So what is C programming? C programming is one of the programming language that is commonly used in system software development. Embedded software development, kernel development, firmware, middleware, and driver development, file system development, and many other applications. C language is a general purpose language and it's efficient and easily portable. So we go to the next. C language keywords categories include, we have the data types, we have the modifiers, qualifiers, we have loops, jumps, decisions, classes, derived, user-defined, and other functions. A typical C code contains the following. We have the preprocessor statements, we have the global declaration, and finally the main code. As shown below, this is a simple code which having the header files, the directive, the start of the program, comment statement, and program terminations. Let's look at the number systems. Numbers are generally represented as either decimals, octal, hexadecimal, and binary numbers. Computers understand only two states, high and low, making it a binary system. A binary system consists of zeros and ones. So let's talk about data representation in computers. We have bits, bytes, and word. So what is a bit? A bit comes from the word binary digit. It is simply a basic unit of information in computer and digital communication. It is the smallest addressable unit of memory in a computer, commonly consists of 8 bits. What is a word? A word is an amount of data that a machine can fetch and process at one time. So let's talk about basic C data types. We have the integral data types, we have floating point data types. We have also modifiers and qualifiers as shown. We have conditional construct, we have under conditional construct, we have single iterations, multi-iterations. Now let's look at a simple syntax of a single iteration construct. We have the if into bracket a condition. If a condition is met, a statement or rather a program is executed. A statement is executed if the condition is true. If it is false, the program terminates. Let's look at if else. In if else, we have if a condition. If a condition is true, the first statement is executed. If it is false, the program shifts to the else part, which executes the second statement. That is if else. Let's talk about switch. Switch case, we have switch and then the expression. So we switch to an expression and then we have case constant. This constant has to be a constant like a 10, 20. So when we switch a case, a statement is executed. If the expression is not true, we go to the second case. If also it is not true, the program goes to default and execute the default statement, the last part here. Let's talk about while. Now here we have while a condition is true, a statement is executed several times. Now what about do while? Now in do we execute a statement while a condition is true. Let's talk about for. We have for, this is a syntax of for. We have for into bracket initialization, then we have the condition to be met, and then we have the post evaluation expression. It can either be I++, dev++, minus minus, then a statement is executed. So as long as the statement is true, a statement is executed until the condition is met. Let's talk about operators. What are operators? These are symbols that instruct the compiler to perform specific arithmetic and logical operations on operands. There are different types of operators. We have arithmetic, including multiplication, division, addition, subtraction, modulus. We have logical. In the logical we have or, and not. Relational, we have less than, greater than or equal to, less than or equal to, equal to, and not equal to. Let's talk about bitwise operators. Bitwise operators perform operations on bits. The operand and the return type are integral in nature. We have the bitwise and, bitwise or, bitwise XOR, complement. We have right shift and left shift. That is bitwise operators. Let's talk about arrays. What is an array? Array is a collection of data of same data type. The basic syntax of an array is as shown. We have the data type of the array. We have the name of the array and the size of the array into brackets. Let's take an example. Int is the data type, integer type, integral type. Then we have age. Age is the name of our array. Then we have 5. 5 is the size of the array, the collection of data to be stored. Now let's take note here. Array avoid repetition where one has to initialize each edge separately. So you don't have to initialize each edge separately. You just store the edges using an array. What are pointers? Pointers are variables that store the address of another variable. It helps in manipulating the values with the help of memory address. Pointers enable the C language become more as a low-level language being a high-level language. Pointers enable returning more than one value from a function. Pointers contain the address of a variable. So pointers store address of another variable. Functions. So what are functions? Functions perform specific tasks in a program. Functions have 3 parameters, including input, operation, and output. The basic syntax of a function is as follows. We have the return data type, function name, and arguments. Argument 1, 2, and up to infinity. Then we have the function body. So this is the basic syntax of a function. What are some of the importances of function? In functions, code can be easily understood and easily modified. Functions are easy to debug and test. Functions are reusable. Then functions are easy to debug and test. And they help one to achieve modularity, where a program can work in modules. So let's talk about passing parameters. In functions, we have pass by value and pass by reference. By pass by value, we copy the actual value of an argument into the formal parameter of the function. What about reference? We just copy the address of an argument into the formal parameters. So these are the two main. Let's talk about preprocessor directives. So header files. Header files contain C declaration and macro definition that are to be shared between several source files. Has to be included using C preprocessing directive, that is #include. See the header file syntax as below. So we have #include, then we have that bracket, the less than and greater than, file.h. This is a system header file. What about a local header file? #include, then we have file.h. Then you can note the kind of marks that are used. So what is a macro? Macro are simple identifiers which can be replaced by a code fragment. They are used to give symbolic names to numeric constants. For example, let's look at a syntax. We have define symbolic name and constant. Example, define buffer size and the constant is 1024. So let's go to the second chapter of what was done. That is project requirement and design, embedded system programming. And we were introduced to embedded system. So what is an embedded system? It is a combination of hardware and software that perform a specific task. And we have several classification of embedded systems. We have standalone embedded system, real-time, networked, and mobile embedded systems. Sorry. Let's talk about real-time. Real-time embedded system can be further be classified into hard real-time, which should meet deadlines, and they are commonly used for life critical situations, e.g. peacemakers in hospitals. Then we have firm real-time, similar to hard real-time, but they mainly involve property. Example, moon rover. Then we have soft real-time. They can have some tolerance in meeting its deadline. For example, a fridge. So, what are the major components of an embedded system? An embedded system must have a memory, a microcontroller or a microprocessor, sensors, field programmable gate arrays, application-specific integrated circuits, diagnostic ports, softwares, and auxiliary system. These are the basic components. Now let's talk about what we did. We did the installation of the development tools. And for a project, we had several tools we used. We had MPLab X IDE. Then we used a PixSimLab simulator for microchip. Then we have X8 compiler. Now, let's talk about microcontrollers. A microcontroller is an IC which is capable of being programmed to perform a specific task. Before selecting a given microcontroller, you must put into consideration some certain factors. For example, the performance, application, the price, the availability of tools, its availability itself, and the special capabilities. Now, what is the difference between a microcontroller and a microprocessor? Microcontrollers has less design complexity, while microprocessors have more design complexity. Microcontrollers are less flexible, and all components are in one chip, while microprocessors are more flexible and has separate components. Now, this is our simulator, the PixSimLab simulator. Yeah. Now, PixSimLab is a real-time emulator for development board. It has several devices that can be connected to the board for simulation. The devices that can be connected to the board are, we have the LEDs, digital keypads or switches, the matrix keypad, the CLCD, the RTC, and the analog inputs, and SSD. Now, what is MPLab IDE? It is an integrated toolset for the development of an embedded application on microchip PIC and PIC microcontrollers. It is called an Integrated Development Environment, or IDE, because it provides a single integrated environment to develop code for embedded microcontrollers. And you can see We have its diagram here. Now, let's talk about peripheral programming, LED. LED are the most common devices used for many embedded applications as feedback. They work like diodes. The characteristics of LED are they have low energy consumptions, longer life, small in size. They're used in many applications as home lighting, remote control, surveillance, displays, and many more. Now, the anode of the LED is connected to the VDD and the cathode grounded. Now on our board, the LED are connected to port B and port D, as shown, port B and port D. Let's talk about digital keypads. These keypads are preferable if the number of user inputs are less. Some common applications of this include the human-machine interface, the mobile phones, computer mouse, etc. Now, there are two main connections of the switches, that is, pull-up resistor circuit and pull-down resistor circuit as shown. Yeah, it's so simple. Now, when digital keypads are pressed, they take output signals in two methods called the triggering methods. So we have the edge triggering method and the level triggering method as shown. The digital keys are connected to port B and as shown below. Now let's talk about the next thing we covered. Interrupts. What is an interrupt? An interrupt is a communication process set up in a microcontroller in which an internal or external device requests the microprocessor unit to stop the processing, attend to the request, and later go back to processing where it was interrupted. The sources of the interrupts can either be internal or external. Interrupts are divided into two, that is hardware and software. Now, when an interrupt occurs, the microprocessor unit completes the instruction being executed, disables the global interrupt enable, places the address from the program counter on the stack, shifts to the interrupt service routine, which handles the interrupt request, and after completion goes back to the main loop of the program. Timers. What are timers? Timers are devices that count down from a specific time interval and used to generate a time delay. A timer uses the frequency of the internal clock RTC and generates delays. Let's talk about resolution with respect to timers. The resolution is the width of the timer register. What is tick? Tick refers to the up count or down count in a timer. What is quantum? It is the measure of time responsible for the tick. Scaling. Scaling allows us to delay the process of going into the ISR if needs be. It can be categorized into pre-scale, post-scale. CLCD. Now, CLCD are commonly used to display ASCII and special characters. CLCDs operate in 8-bit and 4-bit mode. In 8-bit mode, we have 8 active data lines, while in 4-bit mode, we have 4 active data lines, D0 to D7 and D4 to D7 respectively. The CLCD used here is in 8-bit mode. The CLCD in our project is an 8-bit mode CLCD. The CLCD used in the project has a total of 16 interfacing lines: VSS, VDD, V0, register, select, read, write, enable, data line D0 to D7, analog, and as shown in the diagram here. Let's talk about ADCs, analog inputs. An ADC converts analog signal into digital pulses. The ADC application on the PixSimLab simulator is the use of the potentiometer to vary the speed. The resolution of the ADC is the register width. They fall in different categories, including 8-bit, 10-bit, and 12-bit. The ADC used in our project is a 10-bit ADC. Let's talk about acquisition time. It is the time required for the analog to digital converter to capture the input voltage during sampling. Conversion time of an ADC is the time required by the ADC to perform a complete conversion process. Communication protocol. A communication is a set of formal rules describing how to transmit data across networks or devices. Now, integrated circuits, the protocol used here. The I2C protocol is used to establish a communication between two or more ICs. That's why it is called inter-integrated circuit, into bracket I2C. It is a synchronous half-duplex multi-master slave communication protocol. Now, an I2C has two lines interface. We have the signal data line, signal clock line SDA and SCL respectively. It is a bidirectional serial communication with four modes. We have standalone, fast mode plus, high speed mode with their respective speeds as shown the next. Now, a typical I2C communication protocol example is as shown below. That's so simple. Now, I want to welcome my friend to continue from here. Project integration and testing.
I'm going to take you through the project integration and testing. The project in hand is a car black box. So let's start with the explanation. A car black box is a device installed in the car to monitor events like speed, mileage, accidents, and location of the vehicle, also called an event date recorder. It helps to enhance safety standards. The system developed to be password protected in order to ensure that privacy is met. Let's look at the dashboard. A 16 by 2 LCD will be used to display the different events with their respective time and speed. The different speed will be on, gear neutral, gear reverse, gear 1, gear 2, gear 3, gear 4, and collision. To shift between gears, the following keys are used. Switch 1 will be used for collision, then switch 2 and switch 3 will be the up key and the down key respectively. So let's look at the menu screen. To access the menu screen, you need to press either switch 4, which is RB3, or switch 5, RB4, after which you are prompted for a password. The password is a combination of switch 4 and switch 5. So after successful login into the menu screen, there are three options: view logs, clear logs, and the change password. You can navigate the menu by using switch number 4 or switch number 5. Switch number 6 is used to select the desired option. The view logs. These allow us to view the events recorded in the dashboard. Only a maximum of 10 events are stored in the double EEPROM. You can navigate the event using switch number 4 and switch number 5. The clear log. Switch number 6 is used to select this option. Once pressed, the logs are cleared successfully. Now we go to the option of change password. This option allows you to change the password. You are first prompted to enter a new password. After entering the password, you are asked to re-enter the password. If the password matches, it displays the password changed successfully. So I will take you through the simulation using the PixMeLab simulator. So as you can see, we have the board, and on the dashboard we have time, an event, and the speed. The time is displayed in the format of hours, minutes, and then seconds. So as we had said earlier, switch number 1 is used to indicate collision. As you can see, after I press the switch, it is indicating the event C, meaning collision. Switch number 2 is used to navigate up and down. So when I press switch number 2, we have gone to the gear neutral. When I press again, we go to gear reverse, gear 1, gear 2, gear 3, and gear 4. Switch number 3 is used to as the down key. So when I press it, we are coming back to gear number 3, gear number 2, gear number 1, gear number reverse, and then gear neutral. So that is the dashboard. Now if we want to access the menu screen, we're going to use switch number 4 or switch number 5. Once I press it, I'll be prompted for a password. So assuming I don't know the password and I've entered the wrong password, what will happen? So I put the first. Let me enter a wrong password first. We are told wrong password, and we have 2 more attempts remaining. What if I go again? We are told wrong password and we have 1 more attempt remaining. Let me try another wrong password again. Wrong password again, and I'm blocked for 30 seconds. So as you can see on the display, we've been blocked for 30 seconds, and until that second elapses, that's when we'll be allowed to re-enter the password again. So after that second, we'll be allowed to enter the password. So after that second, we're gonna see what if I put a correct password. The menu screen will be displayed, whereby I'll have some option available for me to choose from. Just a minute for it to complete that seconds. So that seconds are over. So let me input a correct password now. Good. Now you can see I have now entered into the menu screen. Into the menu screen, you can see we have some options, and you can navigate through the options using switch number 4 and switch number 5. Switch number 5 is used for the down as the down key, and the switch number 4 is used as the up key, as you can see. So assuming I want to select the first option, which is the view log, how will I select it? I'll use switch number 6 to select it. As you can see, I have some events over there which have been recorded into the WE pool. So I want to navigate through the events. I will use switch number switch number 4 and switch number 5. So let me go down. We have the second event, third event, fourth, fifth, sixth, seventh, eighth. So as you can see, we were able to record only a maximum of 8 events. So what if we want to go back? We only use switch number 4. As you can see, events are being, you can move up and down to see the events as they were displayed in the dashboard. So for me to exit, I will have to use the reset button. So let me go back to the menu screen. Let me enter the correct password. So now I want to go to the second option. Second option, we have it as the clear log. So we have the clear logs. To select it, I'll just need to press switch number 6. The logs are cleared successfully, and I'm returned back to the menu screen, as you can see. So the logs have been cleared, so you don't have any record of the logs. Now let me go now to the last option, which is the change password. I will enter it using switch number 6. So I'm asked to enter a new password, as the one which I wish to be the new password. So let me enter a password. After that, I'll be asked again to re-enter the new password. So let me enter the password again. And the password has been changed successfully. So that's what we implemented in the car black box using the PixMe Lab board. So that was our project. Thank you very much for your time.